that is the mechanical advantage always equal to VR? See, mechanical advantage, the formula that is given in our textbook is that mechanical advantage is equal to efficiency multiplied by velocity ratio. Now, the simple thing that you need to understand is that if we are given an ideal machine, if they have specified that it's an ideal machine, or they haven't satisfied, or they haven't mentioned. If they haven't mentioned, we can assume that it is an ideal machine, and then in that case, the neta would be 100%. So in that case, in an ideal case scenario, the mechanical advantage would be equal to velocity ratio. But it is only in the ideal case scenario. So that is what it is written here, that they are only equal in theoretical ideal machine with 100% efficiency. If the efficiency is 100%, only then the mechanical advantage would be equal to the velocity ratio. But in actual machines, so what happens in actual machines is due to friction, due to energy losses, etc., the efficiency won't be 100%. So this won't be this won't be 1. This would be less than 1. It would be a fraction. Say let us assume that this would be 9/10. Now we understand that once it is a non-ideal machine, that we are now dealing with a case which is a non-ideal case. So what happens in a non-ideal case? Again, to simplify the matters, mechanical advantage is given by load by effort. Now let us assume it like this, that let us assume that we are dealing with a pulley, a single fixed pulley, a simple pulley. Yeah. So in this case, try to assume that this pulley is very old. Say this is a pulley which is say 40 years old. It is rusted. Just try to imagine that it is rusted. It's not being used for a long time. So you understand that you will take a lot of effort to pull this load up. So instinctively you can understand that the efficiency would be less than 1. It won't be working at 100% efficiency. So the effort that you require is far more than the load which it is pulling. Just try to even if we don't have the formula, instinctively we can understand that the efficiency won't be 100%. It would be far less than that. So this in terms of mathematics, of course, the mechanical advantage would be less than 1. It would be in terms of sub-fraction. Let this fraction be, say, to pick a number, let us say it is 6/10. So let us assume that this pulley is working at 60% efficiency. Yeah. Now let us assume that you got it repaired, or you lubricated it, you got a new axle for it. And now what you see is that the load remains the same. Let us assume that you are trying to pull 100 kg load, but you will see that now lesser amount of effort has to be there. Right? The less amount of effort has to be there. So the efficiency has improved. Velocity ratio is given by, in our textbook, the velocity ratio is given by dE by dL. That is the distance moved by the effort and the distance moved by the load. Now, due to friction or due to energy losses, etc., this distance won't change. You can be working with a old pulley, a new pulley. The distance moved by the load and the effort would remain the same. So that is why VR won't be dependent on the friction, load, effort. That is what is mentioned here. It is only dependent upon the design and geometry of the machine. So velocity ratio doesn't depend upon the lubrication or how old the pulley was. So it is an independent factor. So this factor is independent. So in a non-ideal machine, what will happen is that the velocity ratio would be an independent factor. Is the efficiency which is playing a factor now. And that is why in a non-ideal case, the mechanical advantage is not equal to the velocity ratio. That is what is written here. But in actual machines, friction energy losses mean mechanical advantage is always less than VR. So I hope this makes sense. Ratio of MA VR gives machine, so MA VR in the real efficiency, because efficiency is less than 1, so mechanical advantage would be less than velocity ratio. So remember that in a non-ideal machine, if you are given an efficiency of less than 1, 60, 70, 80%, then the mechanical advantage would be less than the velocity ratio. So I hope this was useful. If you want to do more questions on machines, on levers, on pulleys, I have made a long video where I have done a lot of questions from class 10th physics ICSE board. And you can have a look at the comment section. You will find the link there. Thanks so much.